In this video, we're going to think about how we can identify the meaning of gradients of different graphs. So this is a force extension graph, and to identify the meaning of the gradient, we need to identify the equation that is relevant here, which is force equals spring constant times extension. Now, a gradient is whatever's on the vertical force divided by whatever's on the horizontal, in this case extension. So we want to rearrange this equation to get force divided by extension. So if we divide both sides by extension, we get force over extension equals spring constant. So that tells us that the gradient of the force extension graph would be the spring constant. Let's look at another example, a displacement time graph for a cyclist. So there's two ways that we could do this. Whenever you have a something time graph, it gives you the rate of change of the something. So this gives us the rate of change of displacement, which is speed. Or we could look at the equation distance travelled equals speed times time, divide both sides by time, which would give us distance travelled over time, which would equal speed. So two ways when it's a something time graph. For our next example, we've got velocity against time. So the relevant equation there would be acceleration equals change in velocity over time taken. So change in velocity divided by time taken. So the gradient of the velocity time graph is acceleration. But we could also understand it with the fact that the gradient of a something time graph is the rate of change of the something, and the rate of change of velocity is the definition of acceleration. In this final example, we've got temperature against time. And so this is going to give us the rate of change of temperature because it's a something time graph, so it gives us the rate of change of temperature. And this could in fact be used to calculate the specific heat capacity. This last example is the trickiest one, which has got the number of technetium-99m nuclei against time in hours. So this is going to give us the rate of change of nuclei. But this is always going to be negative. So we sometimes would say that this is the minus the rate of decay. So the gradient of this is going to give us the rate of change of nuclei or minus the rate of decay.